Hi everyone, can you hear me? Thank you, Dulce. Thanks, Chen and Mauricio. Okay, so I think I'm going to start the lecture today. Hi everybody, I hope you're doing well. It's the week 5. So as usual, the middle of the quarter tends to be a little crunch on everybody. You guys have projects and midterms and everybody's stressed out. Hi Giselle, hi everyone. It's good to see you all here. Um, so this week we are going to cover the internet and computer networks in general. So you probably all have hopefully done the video lectures on Tuesday and then the quiz. I believe most of you did. I hope that you have watched those videos. I am not going to repeat that content, although it's important content. I'm going to repeat some parts of it, and I'm going to assume that you watched the videos, okay? So what I want to talk about today, the goal of the lecture, is to talk a little bit about the internet, but in very concrete terms, and in particular in the very concrete simulation of the internet that you guys are going to do in this next project that we are, so it's due, part of it is due on Sunday and the other part is due next week. So as you have seen, I hope that you've read the project description, there's going to be a simulated internet that's going to be deployed here in this virtual world. That's an internet inside an internet. We'll go into, like a Russian doll. So I want to talk about the internet, the real one, in terms of the fake one here that we're going to deploy. Because I have a feeling that by deploying this simulated internet in here, you will have a much, much better idea of how the real internet actually works. So I want to focus on some of the differences between the model, the simulated internet that we are doing here and the real internet. And so for that, I assume that you have watched the videos, okay? I hope that you have all learned about, the physical layer of the networks with cables like the Ethernet cable, or what I didn't have videos about wireless, but basically it's another physical media which is wireless communications. So that's sort of at the bottom of the stack, and then there's the bottom on top, which is kind of controlling the access to the media, because the computers uh, when at the bottom layers they're not coordinated, right? So they may start transmitting at the same time in the media, in the shared media, and there are all sorts of collisions. So there are sorts of techniques and protocols for dealing with collisions at that level. And you probably heard, hopefully, in one of the videos you learned about the Ethernet and how it, the media access control layer that controls when and how each computer accesses the shared media. And then on top of that, there is what's called the internet. The internet is a network of networks, right? And we'll talk more about that. It's a very really interesting system design. It's been brilliantly designed to be a decentralized system where no single organization, no single person or company or government would have control over the entire thing. That's what decentralized means. And then on top of the internet protocol, there are other protocols that you also hopefully heard in the videos, things like the datagram protocol, so the UDP, the TCP, the transport control protocol, that's more reliable, and then there are other things on top that I did not include videos. But basically, there's a stack of protocols that makes up the network that we all are using right now, right? Which is an amazing system, really. It's unbelievable how these things actually work. So let me talk about the internet. The internet is, as Vince Cerf, the creator of the internet, said in one of the videos, it's a network of networks. It's not just a network, right? It's a network of networks. What does that mean? It means that at the leaves over here, there's actually a network already, right? So we have in our houses, we have home networks, and those are real networks. They are, we have different devices that are connected to a router, which is this very important component of these networks. And then the router routes packages among the different computers in our house when the traffic is between the computers. And so that is already a network right there. So what is the internet? The internet is an internet working. It means that it's a network of networks. It means that we have these home networks all over, the world on the edges. And then all of these networks are connected to each other via something that is usually drawn as a cloud, okay? And with the label internet, and nobody really knows what is this cloud? What's this magic inside this cloud, right? Well, it's not really. I mean, it's magic in many ways. It's magic, but if you just lift the veil, what's really going on that cloud is a bunch of routers. That's what the internet is. A bunch of routers that route the packets from one computer to another. That's what they are. And so this is real hardware that exists in real buildings out there. And they are owned by real people, right? So this is not just a magic thing. This is, all of these routers are owned by sometimes some companies, sometimes it's governments. So they are, there's actually a model of governance of the internet that somehow resembles the model of governance of the countries around the world, right? So there's an authority that roughly control, and certain countries are more restrictive than others. There are certain countries that completely control the internet inside their country, right? So that's typical cases that people know very well are China and Iran, for example. So China, it has what's known as the Great China Firewall, which is basically, suppose that one of these routers is the backbone of China, right? And so the Chinese government controls everything. It's not just one router. It's a set of routers that control all the incoming and outgoing traffic from that country, right? And so when the governments control those routers, they can just control everything, right? They can sniff the packets. They can check what kinds of protocols, where the packets are going, and and in fact they can let some packets in and not let other packets in. So they control, the people who control the routers control the internet. Okay, that's sort of how it goes. So it's just like, we control the router in our house. We control a lot of what can happen if you know how to configure the router. You can control a lot of what's going on inside the traffic inside our houses. So when whoever controls these routers has a lot of power. But again, some countries are more centralized, other countries are more decentralized. So for example, in the United States, there is no such thing as government-controlled routers. The routers tend to be controlled by companies, actually, because we're in a capitalistic society over here. So the companies are, when the internet became a commercial product, And certain companies came around to, AT&T, and then we have Comcast and Cox Communications and all of the telephone that used to be telephone companies, and then it used to be cable TV companies. They all kind of jumped onto the internet. They already had some sort of physical infrastructure for the other signals that they were providing to consumers, and they just lay down internet cables all over the place, right? And so they are the ones here in the United States that control these routers, and there are many of them, right? So when you move from Cox to Comcast, um, literally there's a switch between these, physical, what physical router are your packets actually going to use when you send traffic between, your house and the rest of the internet. Um, in other countries, it's somewhere in between. The governments control certain parts of the internet, and then the companies control other parts of the internet. So there's all sorts of hybrids in between, being a complete control of a central government and being completely centralized, controlled by many companies or even individuals. So this is what the internet is, a bunch of routers that are owned by somebody. It's important to understand, okay, the governance structure of the internet, because more and more, that aspect is really important. It's not just the fact that this is a brilliant design that has been, this laid out in the 70s. The decentralized architecture is supposed to be not under the control of any one organization, but in reality, there's all sorts of political and social and commercial pressures that have shaped the internet, that actually shape the internet in different ways in different places of the world. That is important to know. And it's perhaps part of the beauty of the design of the internet, because every part of the world shapes what that part of the internet looks like for them. Whatever works for them, is what it is, but it can connect to the rest of the internet too. So it's a really interesting design. Okay, this what's called decentralized architectures, that where no one person or no one organization owns the entire thing, and there's just sort of a partnership going on. So our simulated internet is sort of like that too. So if you read the specifications, you've seen this picture over here. And so I want to explain just briefly what our internet is. Here's what I'm going to do. I'm going to explain this briefly. Then I'm going to go down to details and show you how to set up these routers. Okay, you should pay attention because this is part of your homework. And then I will come back to the lecture here and just focus on the things that are similar and the things that are different between our simulated internet and the real internet. Okay, so that's the plan. So our internet here, our simulated internet, is also an internet. It's a network of networks, and if you read the specifications, you have read that our virtual world here is sort of divided in two continents, right? So there's the north side where I am right now, and then I'm right here in this corner. That's where the auditorium is. There's the south side, and so these are, you cannot cross by walking. If you want to go between one and the other, you have to teleport through the map. So it's just like, it's to simulate two continents, like Asia and America, for example. So and in fact, what's really going on in the real world is that there's these underwater cables, believe it or not. Okay, the internet is actually physical hardware. It tends to be invisible. We tend not to know that it's there, but it's actually there. There's like these gigantic internet cables underwater that connect continents that are separated by oceans. So that's sort of what is going on in our simulated internet too, although all communications here are wireless communications, not cables. I'll talk a little bit more about that. And then in each of these continents, there are two parts, what I call the zones. So on the south side, there's zone 1, zone 2. On the north side, there's zone 3 and zone 4. And what these zones kind of model in the real world might be countries, for example. And the reason is that each of the zones is relatively independent of the other in terms of what's going on. In reality, just so that you know, what's really going on here is that the zones are different game servers in my system. So there's a game server for zone 1, a game server for zone 2, a game server for zone 3, and another game server for zone 4. And when they are together in a logical space, you can see each other, and it looks like there's no transition, but there's actually a little transition. Those of you who have crossed the borders, you probably notice that your avatar kind of wobbles for a while until you finally get to the destination. So that's what's going on, is when you transition between these zones, you are actually transitioning between one process and another, one server and another server. But anyway, so these are countries. But one consequence of these, the fact that these are different game servers, is that the local coordinates, so the X, Y, and Z in each of these parts is different. So it's their own. So the 0, 0 in each of these zones is always on this lower left corner. That's where the 0, 0s are. So 0, 0 of the red zone, the zone 4 is this one over here. The 0, 0 of the green zone is this one down here, right? The 0, 0 of the 3 one is this one over here, right, etc. So everything, when you cross the border, it resets. So 0, 0 is here, and then X grows to the right and Y grows to the top. And so this, the point, for example, 100 and 100 is somewhere over here, and there's another 100 and 100 somewhere over here, right? So the coordinates reset. And this is important for the routing information that you have to provide to the simulated routers. So in each zone now, there's going to be, as you probably already saw, there's these, I separated your tree houses in these streets, right? So there's these streets. You are grouped in streets. The streets have at most 8 tree houses. And so what's going to happen now is, as we construct this network, this model of the internet over here, is that we're going to have, each of you is going to construct a simulated home network on each one of your tree houses. So you're going to deploy a home router and two or more terminals that simulate the computers, and you should be able to then send packets inside your own house. So from one terminal of your house to another terminal of your house through your router, that should work in different directions. So that's the first thing that I'm going to show how to do. But then once you have your home network set up, then the next thing is to do exactly what also happens in the real internet, which is to connect your home router to a neighborhood level router. If you have, I don't know how many of you have actually been responsible for ordering the installation of the internet in your house, but when you get to that point that you live by yourself and you have a house and you ask for the installation of internet in your house, there's actually these routers, physical routers, that are deployed around the neighborhoods by these companies, Comcast and Cox Communications and whatnot. So when you're having problems, and they come and physically check those routers, both at the neighborhood, or sometimes they come and check your router in your house. So that there's actually physical hardware that supports all this magic that we are all doing right now. So the street level routers are model real things that happen on the real internet, which is the neighborhood level routers that are installed by the internet service providers. So you're going to have to organize yourselves by street and place a router on your street, and then connect all of your home routers to that router on the street. That's the first level of internet working, right? So the level 0 is the level of your home network. It's not really internetwork, it's just a network. That's just a plain network. And then the first level of internet working is when you connect your home internet, your home networks to each other through, in the same street. That's the first level. And then, of course, then you should be able to send messages between the different tree houses in the same street. But in order to be able to send different messages between different tree houses in different streets, then you need a zone level router, right? Some router that now connects all of the street level routers And now once you connect all the street level routers to this zone level router, then you are capable of sending messages from any home network on that zone to any other home network on that same zone, right? And then the next level up is to be able to send messages between countries, right? Now we want to send messages between countries or even between continents, right? So in order to do that, then we have the very, very topmost router in our network, which is what I call the backbones. And this again models actual hardware that exists on the internet that are very, very large routers, okay, with lots and lots of cables that come out and in of them. And they're called the backbones. These are really important components of the internet. Okay, so when one of these backbones goes down, traffic on the internet is completely disrupted because basically a big chunk of the traffic goes through those backbones, and if that hardware goes down, that traffic needs to be routed across the world from much longer routes, and it's just a big disruption. Sometimes it happens. Sometimes this happens. So in our case, we are going to have our backbones over here, one on the south side and one on the north side, and it doesn't need to be right here in these exact positions that I just say. You guys figure it out where you want to put them, um, and then you connect them. Again, I'll explain how these connections are done. All right, so this is our simulated internet, and I'm going to now explain and show you here how to set it up, how to set up a very, basically I'm going to show you how to do the first part of the project, which is set up a home network. Okay, so let me just move here onto the virtual world. My avatar is going to stay here, but I'm going to put my camera somewhere else where I can. There's an empty house over there, so let me go to that empty house over there. I'm going to use this empty house as just a temporary housing, just to show. All right, is everybody seeing is everybody seeing okay? The house that I'm showing right now on the stream? Yeah? All right, cool. So here's what I'm going to do. I am going to get the hardware, and this is the hardware. I'll tell you where to get it. But there's two types of hardware. There's the terminals and there's the routers. So the router, I have the router. Hopefully this is the latest version of the router. Hopefully. You know what? Let me do the right thing before I mess up. So this is going to give me a packet. Let me delete this thing out of here. All right, so now I have this network hardware. I'm going to put a router somewhere. So for example, here. All right, so there's the router. There's nothing on it. It's still empty. And I'm going to put a terminal somewhere far away. So, your tree houses, by the way, are 32 meters by 32 meters. And you should separate every one of these nodes by at least 12 meters from each other. Otherwise, they may interfere. As I told you, that this has wireless communication. So just put them, far apart enough, like here. And by the way, I'm going to show you if you want to rotate these objects, because it's kind of inconvenient to always be kind of walking so much. You can just click, edit, and then you can rotate it. So actually, there's a rotate here, and you see that the object changes to that thing, and then you can either rotate it like this directly, or you can give it the exact angle. For here, you could say, okay, rotate by, 170 degrees maybe. No, messed up. 170. There you go. It's sort of like a little bit like this, so that my camera can see. So that's one of the terminals. This is one of the routers. Let's also rotate it a little bit. All right, and I'm going to put another terminal somewhere over there. And again, let me rotate it. All right, so I have these two terminals and a router. So now the first thing that I ask you to do is just to do, there's a button to click here. So let's just click the button. Okay, has a message loaded that is addressed to terminal 2.4.1.10, and this leads me to explain. I hope that you all have looked into in the videos of the internet. Okay, so all of the nodes of the internet, as well as the nodes of this simulated internet, are identified by a number. Okay, and this number is typically, it's just a number, but the way that we see it is represented by this dotted notation because it's more convenient for us. So it's, because these different parts mean different things. So the 2 means that it's the region. So, okay, it identifies the region. So this is region number 2. The 4 identifies the street. So this is street number 4. The next one identifies the house inside that street. So this would be a house 1. And this one would identify some terminal in case I have 10 computers, whatever, 10 terminals. We don't actually need to specify, when we send messages here on this simulated internet, we don't need to specify the terminal. We can just say 0. And what that means is just it will choose one of the terminals. If there are many in the destination, it will choose one. It doesn't matter which one. So we don't have to necessarily know exactly what terminal we want to send the message to. If we put 0, it will show up somewhere on the right house. So there's a message loaded here. So if I press send, this is the messages. Okay, the messages in this simulated network are actual, pink objects. Why not? And if you try to send a message without having set up the network, which is what just happened now, the message will stay here and nobody will tell it where to go. So it will stay here, and after some time it will just poof and disappear. I think I have a timeout of like 40 seconds or something. So after 40 seconds it will just disappear because it wasn't sent anywhere, and it's just sitting here doing nothing. So that is one thing that you can try. But now we need to set up the network. So what that means is that we need to connect. By the way, the message is gone. We need to connect the terminals, both of the terminals, to the router, right? So we need to say, okay, I'm some terminal number and I'm connected to you, and now the router needs to know where this terminal is, where in the space the terminal is, so that it routes the messages there. And that's about it. It's pretty simple. So you have to set up a communication both ways. So it's two different directions. It's from the terminals to the router and from the router to the terminals. Okay, and these are 2 different things that you need to do. One is called upstream. So from the terminal to the router is called upstream. And from the router down is called downstream. Okay. So let's start with the basics. First of all, I'm in some streets in the yellow zone, so I'm in zone 3. I need to know what street am I on. All right, so you're going to go here to the beginning of the street. You're going to check what is this street. Okay, there you go. I'm on zone 3, street 3. That's where I am, right. So now I know I'm in some house. And now you guys, by the way, have to negotiate how you're going to give numbers to your houses. I can suggest something. So I would suggest, for example, 1, 3, 5, 7 on one side, and then 2, 4, 6, 8 on the other. But or you can do 1, 2, 3, 4, 5, 6, 7, 8, whatever. You guys figure it out. Okay, within your neighbors, you can negotiate what the right numbering is. So I'm just going to assume that my house is going to be house number 2. Okay, 1, 2. So I'm going to, and so I'm in zone 3, street 3, and house number 2. So that is my identification. So how do I set up my identification? I right click on here. Okay, Noel has a question. What happens if it says load message first? Load message first. I don't remember that. By the way, when you Noel, let me explain. Right now, since my avatar is physically in the auditorium, I'm just moving my camera. This will not show a bunch of messages that these terminals kind of spit out in the chat channel. So as I was developing this code, I had to kind of debug the code, and so I spit out like just debug messages, status message, like I'm loading the, I'm loading the message, I'm, I'm initializing, I'm doing whatever. So those are all things that. Um, so Nicholas, just hold on a second. I will answer that question next. Those are all messages that the terminals and the routers all send to the chat channel around, within like a 10-meter radius around, and you may listen to those things. Okay, so that's the debug messages of the terminals. It's sort of a status information. Okay, it's just telling you what is going on. So Nicholas has another question. How will we get in contact with our neighbors? That's a very good question, and it's also specified in the project description. But I will tell a little bit about that. Okay, so let me just set up this home network first, and then I will explain how you guys can coordinate with each other. Okay, so let me set this up. I was in 332, right? That was my house, 332. So hold on. I'm going to right click and edit, all right? And the identification information is going to be here on the general tab, on this tab, general. And in here, there's two fields that are important. There's the name and the description, okay? The name is supposed to have the identification, so the address of this terminal. Okay, so this terminal, network terminal, it was on zone 3, street 3, house 2, and I'm going to say that this is terminal number 1. Okay, so that's my address right now, 3321. This is the address of this guy. And now the upstream, hold on just a second. Before I do the upstream, let me go to the other guy, the other terminal, and give it its own ID. So I'm going to edit again, go to the general tab. On the name, this is going to be 3322. And these are all dots in between, 3.3.2.2. Okay, so this is going to be terminal number 2. All right. And by the way, I also need to give an IP address to the router itself. So I need to also give an address to the router. All right, so the router is going to be just 332, because the home routers just have 3 parts, right? So, and this is part of the slightly differences with the real internet. This is a simplification of the internet that I will talk a little bit more after I show you this. But the home routers only have 3 parts. They identify the zone, the street, and the house. That's all you need to identify a home router, all right? So now everybody has its own ID. Great, that's the first part. Now, the next part is to connect the terminals to the router, and then the router to the terminals. Okay, this is done in 2 different ways. So let me start with the first one, which is connect the terminals to the router. So the terminals being able to send messages to the router. The way that this is done in this simulated world is as if I would lay down a cable from the terminal to this position in space. Okay, I would lay down a table. So I need to know, where am I taking the cable? What's the X, Y, and Z of this router, right? This is where my end terminal is, right? So the end of the cable is going to be there. So I need to know the X, Y, and Z, the coordinates of this router. Okay, so how do I know the coordinates? Where is this in space? And that's why I was talking about the coordinates a little while back. So if I go here and again to add edit again, all right, on the object tab, if I click on the object, in here, right here, there's the position in meters, all right? These 3 numbers, X, Y, and Z. This is where the position in space in local region coordinates. So this particular router is in 353 point something, 308, Y is 318, and Z is 22 point something, all right? So 23, almost 23. So for the coordinates, we don't actually need the decimal part. We can just round it up and down. And so I'm going to write it down on a paper, which is 354 essentially. 354 is the X, 318 is the Y, and 23 is the Z. All right, so I'm going to write it down because I cannot remember these numbers. So now that I know where this is, I'm going to sort of lay down the cable to this end, which is going to be done like this. I go to this terminal, I edit it again. So in the general tab again, there's the upstream. So now this is in the upstream is where I'm going to put this information. The upstream is to connect this terminal to the router. So this is supposed to be the location of the upstream router. All right. So it's going to be 354, comma. Okay, this is a comma 318, comma 23. All right. So now I have set up my upstream connection to the router. All right. This guy, if you click, if you put the mouse on it, it should show you both the name and the upstream. I don't know if you can see it on the stream, but it should show you the name, the terminal ID, and then the upstream, the location. Okay. So I'm going to go to the other guy and do the same thing. On the location over here, what was it? 354, 318, 23. All right. Okay, so I set these guys up. Now, one thing that you also need to do, because we are configuring these simulated computers, typically, and this is also true in general, when you change configurations, you need to reset things, right? You need to click the reset button. So in here, we're going to have to reset it because we changed this configuration. So we're going to reset this guy. So it's like right click again, more again, then scripts, then reset scripts. Okay, so it's 2 times more, and then scripts, and then reset scripts. That one reset, and then I'm going to do the same thing over here. More, scripts, reset. All right, so these 2 guys should be good to go. Now with these guys, when they send messages, they know, and let me show you. When they send messages, now, when I send a message, you will see a message going from a terminal to the router, but then it will be stuck there. So let's try that, right? It should know where to send the message now. So let me try that. There, okay? So the message went there, but then there was nothing there and it just disappeared because this guy didn't know what to do with it. We don't have any upstream information in here. If I click on the router, the upstream information is still nothing there. We don't have anything yet here to tell it where to send it next, right? So it just dies right there. Okay, so but now we want to send a message from one terminal to another. Means that the message goes from this terminal to this router, and now the router needs to know where to send the message. If it's inside the same home network, it needs to know where to send the message. So how are we going to do that? We're going to load, this is downstream information, right? So we're going to load in the routers. The router information is going to show up here, and it's going to be similar to the computing machine that you guys used before. We're going to drag note cards onto there. So let me create a note card over here. Okay, and so the note cards is supposed to have 2 parts. You just say, you know, the node and then the column, and it's going to be the identification, so node 1, and then it's going to have position and then XYZ. So for this, I need to know the XYZ of that terminal. So let me go there, and this is where 377, 316, 23. All right, that's the position of that guy over there. So I save it, and now I go here and just drag it here. Oh, you guys are not, sorry. Yeah. All right, the first one is there, but then I also need the position of the other one over there. So the position of that one, and you can only load 1 at a time, okay? I didn't do 2 at a time. So the position of this one is, so this is node 2, and the position of this one is 366, 294. Okay? So we have the position of this guy on this note card. We're going to go there and just drag it from my inventory. Let's see it. There. I'm going to drag it from my inventory onto here, and this is going to accumulate. Okay, so this one now has the routing information for the home network. So this router knows where to send the messages downstream, so to the terminals. When messages arrive here from the outside or from inside, when they arrive at this terminal, and if they are addressed to terminals inside this network, it knows where to send them. Right? We have the cables, the virtual cables laid down. We know where the cables actually end over here, and the other cable ends over there. So that's where the messages go. All right, so now we're all set. We set up our home network, so let's try it out. So now we should send the messages from one terminal to another. So we need a message node, so how do messages look like? First, they need to have a destination address, okay? The first thing is a destination address. So this guy is 3.3.2.2. So if I'm going to send this one is number 1, I'm going to send to number 2. Hello. Okay, so this is my message. And like in the computing machine, if you want to load a new message, you should click on the previous one to delete it. And now I'm going to load a new message. Okay. So there's a new message. Now I'm just going to zoom out so that you can see the messages going around. All right, let's see if this works well. Okay, this view is okay. So let me click send, see what happens. Cross fingers and didn't do any mistake over here on the configuration. So here we go. All right. Uh-oh, it looks like something went wrong. So the message disappeared. Oh, you know what? I need to reset this guy too because I gave it an address. You know, I forgot to reset that. Yeah, I gave it an address and I forgot to reset it, and it's a pain in the neck because if I reset it, the routing information is gone. Okay, so this is a great problem to have because this shows you might run into this problem too. When you reset this guy, the routing table is going to disappear. So the routing table is sort of on memory, right? It's in memory, and when you reset it, it goes away. So if you have to reset routers before you reset them, I recommend that you write down the information on a note card. So let me write this down. So this would be one. It's three. I'm sorry. This is node 1 position 377 316 23. And you know what? I'm going to, even though it takes only one at a time, I'm going to write them both already. Okay, I have a question over here. How do we determine what number our terminals are? So, Brendan, inside your house, you can just give the terminals numbers whatever you want. It's up to you. Again, it's a network of networks. The number of your terminals inside your house, it's up to you. The number of your house on the street, you have to negotiate with your neighbors. You guys need to figure out how you're going to number your houses in your street. And I will explain a little bit more after I set this up, how you can coordinate, okay? So let me just continue over here. Node 2, I'm writing these two, but the terminal takes only one at a time. But I'll tell you, I'm going to do position 366. 294 23. These are commas on my note card. So anyway, let me take this out, save it. So now I'm going to reset the router finally. Oh, I'm sorry. Reset it. All right, so the routing information is gone. I'm going to load the 1. And now I'm going to load the 2. All right, so hopefully everything will be fine now. So let's try it again. Trying to see what's the best. Okay, there you go. All right, so let's cross fingers again. Yes. Okay, it arrived there. Yay! Everybody should be clapping right now if this was a real lecture. So, message delivered. So you will see the message delivered on the left side panel. So the left side panel is the one that shows the messages that have been delivered to your terminals, okay? So from 3321 to 3322, hello. All right, so we have our home network set up. If you want to add more terminals, you can. Just make sure that you connect them to the router properly. And that's basically your homework one. You know, the thing that's due on Sunday is what you need to do here. So let me now address the question that has been asked now twice. How can you coordinate, how can you know the number of your street? I can suggest some numbering systems. I would suggest that if you look at your street like this, okay, from the point of view of this is the mark, the mark on your street like this, I would say 1, 2, 3, 4, 5, 6, 7, 8, like a U shape, okay? That's what I would suggest. But the best thing is that you all, there may be people who are not watching this lecture and they may be completely clueless. And so what I have done is that I have created lots of groups here in this world. There's groups that you can chat when you are all logged in. For example, right now, since you are here in the class, I suggest that you go here. So how do you sign up for these groups? So go here on the search button and then go on groups. All right, and then you search, for example, for street. And there's all of these groups that I created, and I see that some of you have already signed up. Good people, good students, very good. I don't know who you are, but that's awesome. So pick your street. All right, so I'm here. This is street 3.3. So I would pick this street over here, and I would click join group. All right, and I'm just going to click it just for fun. Okay, join group. All right, this should have worked, hopefully. It likely worked. It's just that the group information is cached, so it'll take a while to update. Anyway, so once you are in this group, and everybody in the street is in this group, and if you are logged in at the same time, you can all chat with each other by going like this. So you can click on the easiest thing to do groups is go here on your avatar, your own avatar, and then you say groups. And then you are, this is all the groups that I belong to. So for group street 3.3, then I can IM/call. I say IM and say hello, street 3.3. Anyone here? All right, I don't know if anyone in street 3.3 is here, but if they are here and they're signed up, they should. What comes first, the street or the zone number? It's the zone number, okay? So remember, this is hierarchical, and the numbers are from the top of the hierarchy to the bottom of the hierarchy. So it's the zone number, the street number, the house number, the terminal number, right? So, but besides before I forget, so besides the street groups that you should all sign up right now, since you are here in World logged in, there's also the zone level groups. So if I say zone, there's zone 1, 2, 3, 4, 1, 2, 3, 4. So you should sign up for your zone. So, that house was on zone 3, so you should sign up for zone 3. So sign up for your zone. And this will have, the larger group, like 40 students. No, actually, yeah, 40 students, about 40 students that will be in each of the zones. Okay, and there's more because we're 3 levels up, right? So if you search for side, there's also a group for north side and south side, and I should give an award to the south side people. There's already 7 of them that have signed up for the south side group. Awesome. So definitely the south side wins this race. I wish I had chocolates here to be able to give out. Very good. So the south side people were ahead of the north side people. But so you should sign up for these 3 levels of groups. So the streets, the region, the zones, and the sides. So north side and south side. And that the north side and south side should be really large groups, about 80 people each one of them. So the good thing about these groups is that you can communicate with each other, chat, text chat with each other while you are logged in. It does not work when you are not logged in. So if you need to coordinate when you are not logged in, then you're going to have to find some other way. Maybe, I don't know, Piazza, okay? Put a post in Piazza that is, the title is, whatever, south side issues or north side issues or street 3.3 issues, something like that. You can communicate asynchronously. That's one possibility, that to use Piazza like that. Or you can Discord. Yes, Nicholas, you can definitely use Discord. If lots of you are already in Discord, I have not signed up, not even as an alliance. I have no idea what's going on in your Discord server, but it seems like a really useful resource. So if you guys can sign up for the Discord server, and you can just organize there if you want. So whatever works. There's the groups in here that work while you are logged in. Maybe during the classes you can, use it for coordination. And when you are not logged in, then find another way. So Giselle has a question. A student on our street does not have a name on their lawn, so we cannot contact him. Okay, so Giselle, there's a trick. And I know that some of the objects, some of the students did not put a name on them, but there's a trick that you can do to know who owns the object. Okay, so for example, if I go here and if I point, for example, let me see if I see one of you with an object somewhere. I don't see any of you with an object here, but like, okay, so this couch, okay, I'm going to put my mouse over this couch, and it says who the owner is. You see, the owner says now Crystal Opsh. Let me go to some other random thing over some treehouse somewhere. Yep, Giselle. So if I go to some treehouse over here, and even without knowing whose name it is, if I put my mouse over here, it's from Sandy Marcus, this one. Sandy Marcus is this one, all right? So even if the object doesn't have a texture with a name, you can find out who owns that object by just putting the mouse over, and it will tell you. Okay, and yes, you can add students to groups. You can invite students to groups. If you see already, the names there, you can actually, once you are in, I think you can I think, I don't know. Maybe you can, or just leave them some sort of a message or something. Join us on group something or other. Okay, are there any questions about the actual things that you need to do? Let me tell you, it's a crazy project, because for the first part, it's relatively simple to coordinate, because you're just doing your own home network. You just need to coordinate on the numbering of the house. But then the other parts that are due next week, you actually need to set up the entire thing. So you have to put routers at every street and connect them, to your houses. Then you have to put one router in every zone. There needs to be a router, somewhere in here and somewhere in there. All right, that's the zone routers. Yes, Noel. The only thing you need to submit this in this particular on Sunday, this deadline is just the individual part. So it's just the home network part. And again, I encourage you to read all the the specifications, because it also says exactly what you need to turn in. Okay, very detailed specification of what you need to turn in. The group, the larger group deliverables, I gave one more week, because I know it's going to be crazy for you to organize, to organize yourself. In reality, it depends. I'm trying not to be micromanaging how you do it, because I want you to feel, you have to negotiate and figure out what works for you, just like a city or a country would. Okay, but I can imagine certain structures that would work very well. Maybe you can designate one of you to be, the owner of your street router, and another one to be the owner of the the region router, and so if you kind of delegate and designate and elect some representatives that do something on behalf of the entire group, things perhaps become a little easier. I don't know, but whatever works for you. Okay, I don't want to micromanage. um, okay, so this is what I wanted to. Any more questions about the deliverables and the All right, so if there are no more questions about the homework, I want to go back to my slides. And I want just to point out, you know, I think, I hope, okay, another question. Where can we get the objects? Exactly, Xiaxin, very good. I will tell you immediately after my little part of the lecture, because this is part of the objects that you need to take to your treehouse today. I will tell you in a little bit. So let me move on. What I want to just stress in the next 10 or 15 minutes or so is the differences between the real internet and the simulated internet, because I hope that you will learn a lot about how the internet works by doing this project, because you're actually laying your own network. Okay, this is amazing. But there are things that you will be doing here that are not quite exactly how the internet works, and I want to stress those differences so that you don't think that the real internet is exactly like what we are doing here now. What we are doing here is a simplification. There's certain simplifications because it's just a simulation, and I want to stress what those simplifications are. So the similarities are many. So first one is that this is both are networks of networks. It's exactly the same thing. So interconnected home networks, and how do you interconnect it? With a bunch of routers, okay? Bunch of routers, that's typically the cloud that people draw of the internet is those routers that you guys are going to put on the streets, on the zones, the backbone, that's the internet. So it's the same thing. Also, there's similar types of hardware. Basically, there's terminals like computers, cell phones and stuff like that. It's like the terminals, right? And then there's the other types of nodes, which are the routers, right? The routers are, again, we have routers here. There's routers in the real internet, and routers all do the same things. They all do the same thing. They route packets. Some routers are bigger than others. They can handle more connections than others, but that's the only difference, is how many connections can they handle. But what they do is exactly the same. So that's why our home routers tend to be small devices, and the ISP routers tend to be bigger things. Another similarity is in the addresses. So the addresses here are very similar to the addresses of the internet. So it's a number that has 4 parts, and just like on the internet, typically, the internet is not there's a little difference in here on the meaning of these things, but typically the first part of so an IP address looks something like 128.7.13.2. Okay, that's a real IP address. The first part of the real IP address is related to countries. Not entirely a one-to-one mapping, but is relating to authorities, like who owns this range of the first part of an IP address. There are entities that are basically given ranges of IP addresses that start with that certain thing. And there's tables that you can consult on the internet. Who owns that range? Like who owns 128? Like the IP addresses that start with 128, okay? Happens to be in the US. But basically, you can geolocate, you can know which part of the world a person is by knowing the IP address of their packets, because the IP address discloses by the first part discloses to a mixture of geographic and kind of country level kinds of boundaries. So that's the first thing. So that's sort of like the zone that we have here. And then the other ones are also related to sort of smaller authorities. So there's a similarity between what we are doing here and the the real IP addresses. Also, like in the real internet, the packets, those pink messages that we saw, they have the source information, so who is the packet from, and where is this packet going to. So the source and the destination are part of the message. Okay, my messages also have that. Another thing that's in common is that both the real internet and this simulated internet, the packets don't have routing information. So it's not the responsibility of the packets to know exactly to which routers they should go. That is, the packets don't have anything to say about that. The packets are completely passive. They just have where do they go? Okay, where do they want to go? But no, who routes them is the responsibility of the routers. Not, they have no say about the routes. And finally, the routers route the packets according to their routing tables. That's what a router is supposed to be. So there's lots of similarities, many similarities, important similarities between the model that we are doing here and the real internet. And you will learn a lot by doing this project. Now there's some differences. So the real internet, and this is the main difference, is that in the real internet, the routers are connected not as a tree like here, but as a graph. So what that means is that, what I mean by tree, in the trees that our routers, as I showed you, they just have one upstream. There's only one upstream. So a router, for example, a router in your house can only upstream to the router in your street, for example. It cannot upstream to two different routers. Okay, so in our simulated internet, these links are strictly hierarchical. It's a tree. It's just a straight tree. So each parent can have many children, but each child can only have one parent. Okay, there's only one upstream, so that's a tree. That's not the case in the real internet. So in the real internet, the routers can have many upstreams. So they can have many routes to send packets to. And that's a good thing because it makes it a little bit more reliable. If some node, for some one bad thing of the kind of the topology that we have here, because it's a strict tree, if one of the routers in this tree is misconfigured, the entire downstream from there cannot, it's going to be disconnected from the network, right? So if one of you messes up on the street router, that street becomes unavailable, right? Whereas if there were other ways, other routers that could connect to that street, then there would be redundancy. There would be additional routes that could take packets to that street. But so in our model of the internet that we're going to deploy, it's a strict hierarchical structure with a tree in which every router has only one parent. So there's no alternatives, okay? But that's not the case in the internet. In the internet, the routers can have many alternatives. Another thing that is not part of our simulation is a very important part of the internet, which is the domain name system. I hope you have heard about it in the videos that you watched. And so why is this important? Because in our internet, and I will talk a little bit more about this, we're just sending packets at the level of the internet protocol. And it's the lowest one. We just have numbers, right? We don't have names. So we don't have, for example, youtube.com, right? We don't have those names. That only comes when we deploy a DNS, which is actually a fun project to do. If one of you would like to do that in the creative part, I would be delighted to help you. And there are many protocols on top, but in our simulated internet, there's only IP, nothing else. So basically, this is the real internet. We have, the link layer, the physical layer, there's Ethernet, there's wireless LANs, the network layer, there's IP into V4 and V6. And then on top of that, there's like these protocols, TCP protocol, the UDP protocol, and on top of that, application protocols. Bevan is asking, will I be having office hours Fridays? Okay, I can have an office hour on one of those days. Which day would you guys prefer? Friday, Saturday, or Sunday? Not on all of them, but I will be office hours and available. Saturday? Yeah, is that a good time? Okay, I will send a message on Piazza for extra office hours on Saturday. I will send. I need to look into my, my family plans. I'll let you know at what time. Okay, so that is what I these important things, these other important things that are absolutely fundamental for the for the internet to actually work. They are all things that that are designed and implemented on top of the IP protocol, which is the one that we are doing here. So we're staying at the level of just numbers as addresses, just numbers. There's no names. There's no reliability for. So for example, if something is, if for some reason, if the server is overloaded, and you guys are sending lots of messages, and my scripts start, crapping out and failing, some of these messages may be lost. It's totally possible. I haven't stressed this out yet. But it's totally possible that if many of you are sending messages around, some of the messages may be lost, and that's what happens on the real internet. Okay, and for exactly the same reasons. Okay, the routers may be overloaded, and when the routers are overloaded, messages are lost, they are dropped. Okay, so that's exactly, that actually that's not a bug. It's part of the model of the internet that packets may be lost. And so in order to cope with that, the fact that packets may be lost at this level, at the level of IP, that's what these other protocols, called protocols, are on top of it. In particular, the TCP protocol, the Transport Control Protocol. It's a very interesting, very complicated protocol that ensures that even when packets are lost, that eventually everything will arrive there, or not, or there will be a failure and nothing will arrive. It's either the entire message will arrive or nothing will arrive, right? And when the entire message arrives, it's reliable. It's guaranteed to be the message that was sent. And that's a kind of complicated protocol, but you can imagine how it works, right? So imagine that you have message loss, like the messages, they disappear somewhere along the way. So now on the terminals, you can have redundancy, like you can have, for example, timers that, so you can have a protocol that says every packet that I send, the destination should send me back some other packets, kind of acknowledging that it received that packet, right? So now you have this extra messaging, right? So this is things that are on top of the basic messaging. You say, okay, I send a message to you, and now please send an acknowledgement, send a receipt. And when I receive that receipt, then I know that you received it. On the other hand, if I don't receive that receipt, it's either because my message was lost or the acknowledgement was lost. And in any case, I'm going to send the message again. Okay, so now there's all sorts of extra messaging. That's how TCP works. Okay, nothing of that is implemented in this in simulated internet. So it's just staying entirely at the level of IP. Okay, so UDP is a protocol that sits on top of IP, that the only thing that it adds is just a port number. And this is just, so what does this add to IP? Suppose that the terminals are actually computers, like, your laptops where you guys are right now. When that's the case, the computer can run many programs, right? It can run, it's running the Firestorm program. It's probably running your web browser connected to the Discord server. So there's many programs that are running on your computer. So when a packet arrives at your computer, it needs to know to which program is it going to be delivered. Okay, that is an additional part of the address that is a port number. So it's something that is added on to the right of the IP address. That is a port number. So each program has a port number. All right, so that's what UDP adds on top of IP, and they add some other checksum for error correction. TCP is the big gorilla, okay? That's what you need to know. But TCP is a protocol on top of IP that ensures a level of reliability, okay? This is a very, very complicated thing to do, as you can imagine, okay? It's extra messaging going back and forth, acknowledgements, timeouts, having to number every packet, is all sorts of complicated things. But it's a very interesting, a protocol that is used by pretty much almost all network programs out there. So yeah, I could go give another lecture just explaining, what protocols, for example, is Firestorm using, or what protocols is your web browser using. That's maybe I'll give another lecture. So another thing that is also very important is the domain name system, which is the phone book, right? It maps names to numbers, because we cannot remember numbers. Numbers, that street over there, I already forgot what it was. 332 whatever. It's just numbers don't really click for us, so names are much better. And so the DNS is literally just a phone book. It maps names. You say, okay, I'm whatever name, and here's my IP address. That's it. So, and people can send information to these DNS servers, and they can be looked up. So that they do two things. You can store information there, or you can look up information. That's what they do. And the real DNS is actually super, also very interesting system. It's decentralized. It's not just a single central server that has all the information. It's many servers that have the information. And then, of course, there's HTTP, that is the protocol of web servers that sits on top of TCP. There's SMTP that's also on top of TCP. That's the protocol for mail servers. There's FTP, again, another one that sits on top of TCP. That it's a protocol for file transfer. So lots and lots of product application level, it's called application level protocols that use TCP to send packets reliably. Okay. So I just wanted to make big disclosures about, make sure that you know the differences between what you're doing here and what is similar with the internet and what is different from the internet. And in particular, the most important thing is that topology is not quite the same. Okay, that we're using here is just a tree because it's just much simpler. And the real internet is actually a graph, not just a tree. Okay, so having said that, let me go back again to some of the questions here. One of the questions, where do I get these objects? Well, let me tell you, right here. And by the way, since I'm looking at this, don't forget to click this attendance button, all right? And right here, click me for nodes. And there should be objects on both sides of the Atlantic here. Click me for network nodes. So if you click in here, you will receive a oh, somebody's hi on zone 4. You will receive a folder that's called the network hardware. And then inside that folder, you have the network terminal and the network router. So in mode of finishing up this lecture, before you go to your treehouse, I want you to spend the last 5 minutes going to your treehouse, and you don't need to come back. But please go to your treehouse and at least put those objects on your lawn, okay? So that I know that you were here and that you did the class activities, putting your objects on your lawn. And since you're there, you might as well start, connecting things up if you're while it's still fresh in your memory, okay? Any other questions? All right, there's no more questions. I'll see you all on, I guess, Saturday or later. I also have office hours in a little bit. I'll see you later. Bye. I like sitting in the chair. Yeah, it's nice. Thank you, Giselle. Yeah, get up. Exercise your virtual legs. Come on. All right. Bye, everyone. I'm going to stop the stream now.